Assalamualaikum.
Hi.
Hello? Hello?
Yo.
My name is Hazika binti Sazmi.
My name is Yasmin binti Zakaria.
My name is Aswanadia binti Muhammad Noor.
My name is Azrin binti Zainuddin.
We are from Group Kalima and our project title is Mainspring Damper System. So, there are a lot of effectiveness of mainspring damper system and has been widely used in any area of it. So, in the real life of application of mainspring damper system, such as the shock absorber assembly of a motor vehicle. So, as an example, when a car goes over a bump, the spring in its shock absorber assembly is compressed by the elastic potential energy of the spring, immediately forces it back to a position of equilibrium. Thus, the pump is not felt throughout the entire vehicle and smoothen the ride. Welcome back. So, the mainspring damper system is also known as vibrating system. So, when the value of the transmitting the energy into the system at a certain time and cannot be predicted, then the vibration occur are named as random vibrations. But if the vibrations occur because of its elastic and inertial properties, thus the vibrations are called as free vibrations. So forced vibrations can be produced when there exists an external force in the systems. And the stiffness in any continuous systems is the force per unit deflection, while the damping is the force per unit velocity. However, in our study, we focus on to determine the time taken when the mainspring damper system reach equilibrium. Next, I will pass it to my friend.
Alright, after knowing what mainspring damper system is, let's see how can we relate this system with second order differential equation.
Okay, so this is a picture for our mainspring damper system. As you can see, it lies in horizontal direction with an object moving in horizontal direction. So here is our spring and this is our damper. Okay, now let's go back to our topic on how do we relate this system with second order differential equation. Newton's second law stated that the acceleration of an object is dependent upon two variables, which are the net force acting upon the object and the mass of the object. So, after we substitute all the values into the equation, we will get this equation. And then after we rearrange this equation, we will get second order differential equation. So, when the object is moving to the right hand side, Ft or force applied to the object is in positive value, while both K and C are in negative value since they move to the opposite way. So, if we multiply both equations with M, we will get new equation, which is net force equals to Ma.
Okay, so in this system, damper works to resist or oppose the motion of the spring, which is contraction and expansion. Now, let's go to Asma.
Thank you, Ai. Now I will show you how to solve the equation. Let's take a look at the problem statement.
So we have here is the equation of motion for an ideal spring mass system with damping and an external force.
We can see there's a lot of unknowns here. Therefore, before solving, we need to define this unknown first. Given that F is the external force, M is the mass, C is the spring constant, and K is the damping constant. The values that we choose for this problem is M equals to 1, C equals to 5, K equals to 4, and F equals to 2. And here, we have the initial condition for this problem. Next, we can just substitute those values into our problem. And we will get this second order differential equation. Now, we know that we have to use Laplace transform to solve this equation. So, perform Laplace on both sides of the equation. and separate the expression into 3 different terms like what I did here, so that it will be easier for us to perform Laplace. Okay, so after using Laplace transform on both sides, we will end up having this equation. Looks quite long, but don't worry. From here, just expand the equation and solve what we are able to. Then we need to use xs as the subject. So factorize out xs. Leave xs as the subject on the left and bring all the other terms to the other side. When we finally get xs, remember to factorize the denominator of the expression on the right and simplify the expression to its simplest form. The next step would be separating this expression into 3 terms. Okay, let's continue. To separate the terms, we will use partial fraction. Okay. So for partial fraction, we just need to find the value of a, b, and c and substitute them back into the expression. Now, we can see that it's easier for us to perform Laplace inverse. Okay, last step. Come on.
To find xt, we just need to perform inverse Laplace on xs. Separate the terms and perform inverse Laplace on each of the terms, and it will finally give us the solution to this problem. Yay!
Problem solved, but not done yet. Relax.
We need to plot the graph for our solution.
Okay. We know that our solution is an exponential equation, so our graph should look like either of these exponential graphs. To plot, choose any positive values for time, and this is how our graph looks like. As you can see, when time increased, the displacement also increased until it reached one point where the graph is in a steady state. So, this actually means that after a certain time, the mass spring damper system will reach its equilibrium state. During this phase, the displacement of mass will barely change over time.
From the result, we can say that as time increased, the displacement also increased until the mass spring damper system reaches its equilibrium state approximately 4 seconds after the force is applied. It's done.
No, we're not done yet, but still I'm not gonna use this. As for conclusion, in our project, we are able to learn about the application of Laplace transform in the studies of physics, focusing on the spring mass damper system. And we're also able to solve the problem by using Laplace transform, which is by obtaining the time where the system reached equilibrium. And we managed to improve our skills in using MATLAB to solve mathematical problems and plotting the graph. From the view of Islam, we are encouraged to seek knowledge and make researches throughout our life. And throughout this project, we have the chance to study other fields too, which is physics, and can relate them to mathematics. The knowledge of Allah is so vast, and we as humans need to have passion to learn more about this world and its phenomena. And now it is finally done.
Thank you.
Thank you.
Thank you.
Have a nice day.